Okay, if I get your attention up front, we're going to get started. Shh. All right, we're starting today. We're talking about inverse functions. Inverse functions in non-mathy language. An inverse function undoes the original function. Yeah? We have an example if you were in my stats class where we take a data value and turn it into a percentage. The inverse would take the percentage and turn it back into a data value. They move in opposite directions. X goes to y for the function, y goes to x for the inverse function. They map in opposites, yeah? In math terms, an inverse function is one in which the input of the original becomes the output of the inverse, which gives us a clue in how we find them. The x and the y are switching roles. Can you think of any examples that we have seen of functions that undo each other? One where if you do the one function and then the second function, you just get x back out. Functions that undo each other. I'm going to give you like 90 seconds. Discuss with your neighbors. Don't judge me. It is cherry Dr. Pepper. I wouldn't say I have a ton, but I like them. I buy them regularly, yes. Do I what? I do not. That is, as a matter of fact, is the last one I have for the day. That is it. I bring them in my bag with me to school. I don't keep them in my classroom. So no, I do not have enough to pass out. After Williams, after they check my classroom to make sure I don't have that, I'm going to bring my mini fridge back, and then I will have food and liquid in my room. What? They check our classroom. I have to, on Monday, take all the extension cords out and hide them. I have to take all the stuff off the top of the shelf. And they're going to check that you guys have your Chromebooks because you have a digital textbook. You need your Chromebook to access it. Yeah. Okay, who's got an example for me? Two functions that undo each other. Any examples? I know you know of at least one because you would have seen it in Math 2, I believe, when you were learning to solve quadratics. Ooh. Whoops. Squared and how do we undo squares? Square roots. Heck yeah. Heck yeah. It's a perfect example. Multiplication and division are operations and not functions. You are correct that they are inverse operations. They undo each other, but they are not functions. Good. Good. Very good. So we're going to look at the formal definition. We're going to talk about some warnings, and then we're going to do some examples to give you some practice. So, the important part. For any one-to-one function, bless you. For any one-to-one function, f of x equals y, a function f inverse of x is an inverse function if f inverse y equals x. This can also be written as f inverse of f of x equals x. There's a lot of mathy terms in there. Blech. When we read them out loud, the f with the -1 exponent is read as f inverse, F inverse. And when you see it used in function notation, it is read as F inverse of x, if I could spell. And there are two warnings before we do some examples. The first warning is that when I write F inverse, x to the minus 1, that does not equal 1 over f. That right there, this thing right here, that's called a reciprocal relationship. You've heard of that word reciprocal before. You learned about it when you flipped a fraction upside down. That's what we're doing here. F becomes 1 over f. That's a reciprocal relationship. That is not the same as an inverse. Inverses undo each other. They don't flip each other upside down. So this is F inverse. This is the reciprocal of F. Separate things. So we need to be very careful about how we use vocabulary now. You had a question, Gerardo? Reciprocals cancel each other out when you multiply them, not when you use the output of one function as the input for another. Right, but only through multiplication. Yeah. So an inverse is I have my function here, and then I use that function as input for my input function, my inverse function, and it spits back out the original input. For example, if my original function is x squared, I know the inverse function of x squared is square root. If I do square root of x squared, what do I get? I get x out, yeah. It's a function inside of a function. It's not a function times a function. Reciprocals is one times the other. This is one inside of the other. Exactly like f of g of x, except now f of x is the f inverse and g of x is f. Yeah, it's a function inside another function. Nested functions, yeah. Yes, Bruno? Possibly. What was your question? So this is a nested function. We call them composite functions. The outside function is f inverse. The inside function is f. And if I do f inverse of f, they undo each other and spit back out the original input. That's what the definition of an inverse function is. Yeah? And the example, the x squareds. F is the name of the function. And we use the letter f because it starts with f. Yeah. I don't know, but it's okay because I'm not judging. All right, the process. And then some examples. Yeah. First process. In that box, the very first thing you wrote down was 1 to 1. We need to check that our original function is a 1 to 1 function. How do we do that? Ooh, how do we check that a function is 1 to 1? By what? How? How we check our work? I see you drawing lines. That's how we check that a relation is a function. There you go. Luis has got it. We use the horizontal line test. Good. Come on, pen. There we go. In other words, you're going to check your graph. Yeah? You have access to your graphing calculator. You have access to Desmos. Look at a quick graph. You know what toolkit functions look like, right? So you can look at the parent function and make a decision looking at that graph. Yeah, good. If it fails the test, if it fails the horizontal line test, if it's not a one-to-one function, there are some things that we can do about that we're going to talk about on Monday. So if it's not one-to-one, we're going to have a second step off to the side, a branch. Today, we're only going to look at one-to-one functions. If your function is one-to-one, we switch the position of x and y in the formula. Because that's what inverse is, right? It switches the roles of x and y. Just flip them. And once you've flipped x and y, you solve for y. Get y by itself. Isolate it. Yeah? Algebra. Reverse PEMDAS. Work from the outside in. Get y by itself. Yeah? The result of that process is your inverse function. Yay. Check that it's one-to-one. Switch x and y. Solve for y. We're going to do a couple examples. You're going to do a couple examples. Yay. All right, we're going to start with a very common function. Celsius equals 5/9 Fahrenheit minus 32. I'm going to replace this and write it as y equals 5/9 x minus 32 because I think that's a little less scary. And the first question, is that one-to-one? Y equals 5/9 times x minus 32. Is that one-to-one? Take a minute, discuss with your neighbor. I'm going to have us vote about 60 seconds. Is it one-to-one? You should have a built-in answer because I just told you I'm not going to give you any tricky problems. All right. I'm going to want to show a thumbs. If it is one-to-one, you're going to give me a thumbs up for positive. If it's not one-to-one, you're going to give me a thumbs down for negative. Frowny face. I need to see thumbs in 3, 2, 1. Show me your thumbs. Thumbs up, thumbs up, thumbs up, thumbs up, thumbs sideways, thumbs up, thumbs down. So most popular answer is thumbs up. And the question is, people who said thumbs up, how do you know? We don't know. So different question. What is the shape of the graph of that equation? It's a very good, Marissa. It's a line, yeah? That's a linear equation. There's no exponents. It's just a y and some numbers and an x. Yeah? We know that linear functions are one-to-one. As long as they're not vertical, they are one-to-one. And that guy is not vertical. Because vertical only has one variable in it. This guy has 2. He must be a tilted line. Yeah? Good. So, he's one-to-one. We're going to switch the position of x and y in the formula. So I'm going to have x equals 5/9 y minus 32. And I want to solve that for y. I work from the outside in. What should I get rid of first? The answer is the 5/9. How do I get rid of the 5/9? Reciprocal. Very good, because you guys mentioned it earlier. Flip that fraction, multiply it on both sides. Because then I've got 5 on top, 5 on bottom, 9 on bottom, 9 on top. That makes me happy because I don't like fractions. 9 over 5 times x equals y minus 32. Alex, suggestions? I want to get y by itself. Don't shake your head. Move the 32. That's perfect. Why were you shaking your head? Yeah. Plus 32. Plus 32. Yeah. With confidence. So I'm left with y on the right, and 9/5 x plus 32 on the other side. And if you are familiar with converting back and forth between Celsius and Fahrenheit, you will realize that that is, in fact, converting in the other direction. Yay! As a physicist, I greatly appreciate this process because then I only had to memorize one temperature equation. I could derive the other one. Yeah. Fractions flipped, the operation inside is flipped. Yeah. Let's try another one and have you guys help me. You've seen one. I am going to rewrite this. Y equals 2 plus square root x minus 4. X minus 4. X minus 4. The question is this 1 to 1? I will give you a hint. Its parent function is y equals the square root of x. That's in our toolkit of functions. Who remembers what that graph looks like? That's the quadratic. That's its buddies. What happens? We turn it on its side. Yeah, good. Starts at 0, 0, grows like that. Looks like half of a parabola on its side. Is that picture 1 to 1? Yes. Yes, if I start drawing horizontal lines, I'm never going to touch the curve at more than 1 point. There's no points that are stacked on top of each other. Yeah? There's no points that are stacked this way. So it's both a function and a 1-to-1 function. Very good. So check mark, happy face. Next step. Jackie, what do I do next? Step 2. That's exactly right. Let's switch the position of x and y. Perfect. Perfect. Very good. I want to solve for y. I have to work from the outside in. Aubrey, suggestions on what we could do first? You're not wrong. We could do that. Does that look like a pretty thing to evaluate? No. No. Though I agree at some point we are going to have to do that. Suggestions on what we could do before that? Yeah, let's get rid of that constant hanging out in front. I think now that the square root is by itself might be a good opportunity to take Aubrey's suggestion and let's square both sides. Because we know squares and square roots undo each other. Suggestions? Gerardo, what should we do next? Subtract the 4? Add the 4. There we go. That was the weirdest 4 I've ever done. Okay. So I get x minus 2 squared plus 4 equals y. Where's the what, huh? It came, did you get it? We subtracted the 4 and then we had to square to get rid of the root. And I didn't simplify. I left it that way. Yeah. Somebody brought this up in 4th period too. Why didn't I simplify that? I could expand that and then combine like terms with the 4. You could do that, and that would be correct. 1, I'm lazy. I know I'm not the only one in here. 2, that is another way that we write quadratics. That is vertex form. You saw it as a sophomore in Math 2. Your impulse to square it and group all the like terms together, that's standard form quadratic. This is vertex form quadratic. There's also factored form quadratics. All of them are valid. Run with whichever one is easiest for you to write in the instance, yeah? I'm going to leave it this way. 1, because it's easy. 2, I see very clearly the relationship between the original function and its inverse. I had a positive 2, I'm subtracting 2. I had a minus 4, I have a plus 4. I was taking a square root, now I'm squaring something. It makes those connections between the original and the inverse a lot more clear in this form. Right, because the 2 and the 4 switch places. Yep. Good. Good. Now it's your turn to practice. I've got another one on the next page. I want you guys to try C together. If you finish early, take a look at D. D's a little tricky, but I want you to start it on your own. I'm going to give you about 4 minutes, and then we're going to come back together as a class. Julie. So Julie says do this first. Melanie's nodding. Jade is nodding. Is there something we're supposed to do before that? We just flipped the Y. That's what Julie said. Oh, I think we forgot what step 1 is. What is step 1? Make sure it's 1-to-1. It is. I know it is. How do you know it is? It's linear. Good. Very good, Bruno. Just like that example on the front. This guy's linear. We know linear is 1-to-1. Yeah. You have to explain that as a first step. Yeah? Ooh, very good. So Bruno's suggestion is to move the 1/3 next. How do you suggest to do that, Bruno? Subtracting. What's the operation here? Multiplying. Good. So we're going to multiply by its reciprocal. If I want to get rid of 1/3, I multiply by 3/1. 3's cancel, 1's cancel, make me happy. What is 3 divided by 1? 3. Yeah. This is just 3x. And now that there's nothing over there, I can remove the parentheses. Dayanara, what do I do next? We add 5 to both sides, and we get y equals 3x plus 5. Yes? And it looks like that's what most of you were headed towards when I was circulating. Very good. Yeah. Then the next one. We're going to work through this as a class because this one's tricky. Yeah, it's tricky. Alan, what should I do first with D? Step 1. Check if it's 1-to-1. I need to identify its parent function. I see a number over x. So this guy's parent function is y equals 1/x. The question is, what does the reciprocal graph y equals 1/x look like? Yeah, very good. I saw a couple people drawing it. It's got a curve over here. It's got a curve down here. And the question is that parent graph 1-to-1? Jordan, is that parent graph 1-to-1? Yes, very good. There's no horizontal overlap there. That passes the horizontal line test, which means my original function is 1-to-1. Yay! Happy face. Brandy, what do I do next? Step 2. You can check the front page of your notes if you need to. What's step 2? And I know originally f of x, that's another name for y. So now it's going to be x equals 2 over y minus 3 plus 4. Ugly. That looks ugly. You can go ahead and say it. I agree. That looks ugly. That is a great question. So I'm going to remind you, when we're solving for variables, we start on the outside. We work our way in towards the thing we want. So I want the outermost function. Outermost function. Who sees what I should do first? Subtract 4. I agree. That is an excellent suggestion. Because we're subtracting, it's x minus 4. I can't combine them because they're not like terms. And this is where we get stuck. How do I get rid of that y in the bottom of a fraction? My suggestion, as a lazy mathematician, I can turn anything into a fraction by putting it over what? 1. 1. Anything divided by 1 is itself. By doing that, I now have a proportion. One fraction equal to another fraction. And I learned in math class that I can do whatever I want to one side of the equation as long as I do the same to the other. I want to flip this guy upside down so that y is in the top. I have to flip that guy upside down too. It would be, but I meant to do that in a different pen color. It would be 1 over x minus 4 equals y minus 3 over 2. That is less scary to solve because the thing we're solving for is now in a numerator and not a denominator. That is not the only way to do it. If you did it a different way, that is okay. No, she hasn't come back yet. Okay. So now the question is, starting here, focusing on the right, what do I need to undo next? Yes, Jardo. We're going to times it by something on both sides, but remember I'm focused on the side with the y. My suggestion is 2. I want to get rid of that fraction. We do not like fractions. Fractions are gross. That makes the fraction go bye-bye. I am a little concerned about that back table today. So 2 over x minus 4 equals y minus 3. That is something we know how to solve. Perhaps somebody who is not having a giggle fit can help us. Aubrey, what would we do next? Add 3. That's perfect. Yeah. So 2 over x minus 4 plus 3 equals y. Happy face. Happy face, happy face, happy face. Just breathe, guys. Just breathe. All right. So first step is questions on how we're figuring out how things are one-to-one. I'm not getting any questions, but I'm getting some fish-eyed stares at me, so I'm a little worried. Check the graph. Check the graph. Just look at the graph. If it fails the horizontal line test, it's not one-to-one. Yeah? Quadratics fail the one-to-one test because if I pass a vertical line, it touches in 2 places. Right? An absolute value, a V shape, would fail the vertical line test. It would touch in 2 places. Look at the graph. Yeah? If it passes the vertical line test, flip x and y, And then it's algebra. Yeah? Which is good practice because we need to get those skills freshened up. Good? Yes, Melanie. That's our discussion for Monday. We're going to start limiting the domain of our input functions. Good question. Very good question. We're going to address if it doesn't pass, what do we do Monday? Other questions before we wrap up? No. Okay.